Section 4.2, apply congruents and triangles. To start out, let's talk about congruents. So two geometric figures, anything that has shape, they are congruent if they have exactly the same size and shape. Exactly the same size and shape. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. Okay? In congruent polygons, this means that the corresponding sides and the corresponding angles are congruent. So, when you are writing a congruence statement for two polygons, always list the corresponding vertices in the same order. So for this one, I have triangle A, B, C is congruent to, if I look, I went from A to B, which is the one tick mark, so I'm going to go from F to E, which is the one tick mark. So that's congruent to triangle F, E, and then in this one, I went from B to C, which has 3 tick marks. I can go from E to D, which also has 3 tick marks. So you know that triangle ABC is congruent to FED. You cannot say it in any reverse order. I could not say ABC was congruent to FDE because they have to be in the right order. We can also list the corresponding angles. Angle A is congruent to angle F. Angle B is congruent to angle E. And angle C is congruent to angle D. Those are all the corresponding angles. You can also list the corresponding sides, and those are shown by the tick marks. You can say side AB, which is a segment, is congruent to FE. Okay, BC is congruent to ED. And AC is congruent to FD. We can gather all that information from just looking at this statement too. Everything's written in the right order. Segment AB is congruent to FE, segment BC is congruent to ED, and then AC is congruent to FD. Let's try an example. Write a congruent statement for the triangles. Identify all the pairs of congruent corresponding parts. So if we look, I'm going to start at single arc, double arc, triple arc, and match that with single, double, triple. So we can say triangle KLJ is congruent to triangle SRT. So let's list all the congruent parts. The angles first, so those are the easiest. Angle K is congruent to angle S. Angle L is congruent to angle T. And angle J is congruent to angle R. Now the sides. Let me erase this. It's hard to read those. Sorry, let's start over. I'm going to do KL is congruent to SR. LJ is congruent to RT. And KJ is congruent to ST. Example 2. In the diagram, DEFG, we go from D, E to F, F to G, is congruent to S to P, P to Q, and Q to R. They're in the right order. Find the value of X. So you need to compare the parts that are equal. X is, let's do QR. Okay, QR was the last piece. So QR has an unknown on it. We're comparing that to FG, which is right here. So you can say 2x minus 4 equals 12. Add 4 to both sides. X equals 8. Now find the value of y. Y is in this angle Q. Q is equal to F because they're in the same order in the congruent statement. So F is 68 degrees. So you can say 6y plus x equals 68. Luckily we know what x is. 6y plus 8 equals 68. Subtract 8 from both sides. Divide by 6. And we have our two answers. Painting. If you divide a wall into orange and blue sections along segment JK, will the sections of the wall be the same size and shape? Explain. Okay, we can see, if we look at orange, if I write a congruent statement, I can say that A, J, K, D is congruent to, let's look at this. AJ has one tick mark. KC has one tick mark. I'm going to start with C because it's also a 90-degree angle. A is 90 and C is 90. CK, one tick mark. KJ, that's right along this line. KJ is the same as JK. So I can say KJ. And then I'm at J. I'm going to go from J to B, which is 2 tick marks, which we went over here. I'm going to erase this. K to D is 2 tick marks. J to B is 2 tick marks. And then I can say D to A is 3 tick marks. B to C, so D to A is 3 tick marks. B to C is also 3 tick marks. So there's my congruent statement, and they're all the same. Let's see. If you look at all the angles are the same too. Angle A is 90. Angle C is 90. Angle J, let me erase this. Angle J is 1. That angle is 1, where that one's 4, and these are parallel lines because of all the 90-degree angles. So alternate interior angles say that 1 and 4 are the same. So this angle, and then these two angles are also the same because of alternate interior angles. And then D and B are 90 degrees. So all the angles are the same, all the sides are the same. You can say that these shapes are the same. In the diagram at the right, ABGH is congruent to CDEF. Go ahead and try this one. Identify all the pairs of congruent corresponding parts. Sorry, for part 1 for this question, we're not trying to solve for anything. You're just identifying the pairs of congruent corresponding parts, the sides and the angles. So make a list. There you go. I actually didn't look at the shapes all that much. I take all that information from here, which is pretty cool. Can now find the value of x in the measure of angle H. There you go. Another you try, show that those two triangles are congruent. Okay, so write a statement. Give some reasons. Okay, it's easy to prove the sides are congruent if you follow along. Okay, PT and RT both have 2 tick marks, so I can say they're congruent. TS and TQ both have 3 tick marks. I can say they're congruent. SP and QR both have 1 tick mark. I can say they're congruent. So that one's pretty easy. With the angles, you need to look a little bit closer. So if you look, these are both parallel lines, and this is a transversal and that's a transversal. So here, I have 2 alternate interior angles. So the alternate interior angle theorem says P and R are congruent. here, transversal, two parallel lines, S and Q are congruent because of the alternate interior angle theorem. And then here I have two angles, they're vertical. We've learned that parallel lines, actually we've just learned that vertical angles, vertical angle theorem says that that angle and that angle are congruent. So we know that those triangles are congruent. Alright, third angle theorem. If two angles of one triangle are congruent and two angles of another triangle, then the third angles are also congruent. To put a drawing with it, we know that I have two triangles, equal, okay, congruent, sorry, these are congruent, those are congruent. So we can say if A is congruent to D and B is congruent to E, A and D, B and E, then we can say that C is congruent to F. Pretty simple. So let's use that information to find the measure of angle BDC. So we have two triangles here. Here and here. See them? Let's erase that. Alright, so BDC is this whole angle right there, right? So if we know that that's 30, we know that this is 30. We can figure out what n is, but I really don't care what n is yet. Okay, let's write this a little bit better. We know what we're finding. Let me fill in what I know. So this is 30. This is 45. So if this is 30 and this is 45, we can actually find this whole angle right there, right? The interior angle theorem, 30 plus 45 plus x equals 180. And we're saying that is x. 75 plus x equals 180. X equals 105. Okay, let's try to write a proof. Given AD is congruent to CB, DC is congruent to AB, angle ACD is congruent to CAB, and CAD is congruent to ACB. These are all marked here. We need to prove those triangles are congruent. We have a plan for a proof which sort of helps us figure out what to do. We're going to use the reflexive property to show that AC is equal to AC. That will in fact let me put 3 tick marks here and all of my sides are congruent. And then we can use the third angle theorem to show that this angle is congruent to this angle. Okay, let's do it. So, wrote down the given. Said we were going to say that AC is congruent to AC because of the reflexive property. Remember when it sees itself in the mirror, it knows it's equal. Reflexive property of congruence. Okay, we can also say angle ACD is congruent to angle CAB, and angle CAD is congruent to angle ACB. And that was all given. So B is congruent to D because of that third angle theorem. So then we know that ACD is congruent to triangle. Did I say triangle the first time? CAB. That's a C. Oh no. Sorry. CAB. Because of the definition of congruent figures, we learned that if all parts are congruent, the figures are congruent. In the last little definition, we learned way back in chapter, I think, 2, about properties of congruent segments and properties of congruent angles. So I'm going to push pause and write in all of the properties of congruent triangles, and you will recognize them all. There they all are. Push pause and write them down. They should ring a bell. Okay, you try. In the diagram, what is the measure of DCN? Right there. Okay, see if you can figure it out. It's going to be that third angle theorem. There you go. We know that D is congruent to S. We know that these are congruent because they're vertical, so we can say that those are congruent. NDC congruent to NSR. We would need to know about the lengths of the sides. I'll go in blue. We would need to know that these are equal and these are equal. Okay? By definition of congruence, what additional information is needed to know that triangle NDC is congruent to NSR? I'm going to go back one and we can look at it. So we would need to know that DC is congruent to SR and DN is congruent to SN. Because you need all the sides congruent and all the angles congruent. We know all the angles are congruent, we don't know about all the sides. Okay, daily homework quiz. Go ahead and try these. There's one more page. And try that one. Okay? We'll see you tomorrow.